Hello everyone. Welcome to the webinar on NoSQL Era and Schema Design. I'm Sharan Nayak from Cloud.that Technologies, and I will be your anchor for this webinar. I take this opportunity to briefly introduce Cloud.that Technologies and our presenter for today, Sankeet Reddy. For Cloud.dat's introduction, Cloud.dat was incorporated in March 2012. And we provide trainings and consulting services in cloud, big data, and IoT technologies for mid-market and enterprise clients around the world. Right, so with the expertise in major cloud platforms, including AWS and Microsoft Azure, Cloud.dat is uniquely positioned to be the single technology source for organizations looking to utilize the flexibility and power cloud computing and IoT provides. So till date, we've trained more than 7,000 IT professionals and conducted corporate trainings for some of the Fortune 500 companies, which includes Accenture, Infosys, Fidelity, HCL, Intuit, GE, TCS, HP, Western Union, Flipkart, L&T, just to name a few. We have presence in Mumbai, Bengaluru, USA and UK, but also offer on-site and pre-scheduled public batches in different IT-centric cities of India and overseas. Cloud.dat is an AWS consulting partner, Microsoft Silver Learning Partner, Microsoft Silver Cloud Platform Partner, Google Cloud Platform Partner, Red Hat Certified Training Partner, MongoDB Ready Partner. Now coming to Sankeet's introduction, Sankeet is an Amazon Certified Solutions Architect with extensive experience working with Amazon Web Services. He specializes in running MongoDB cluster and has experience in architecting and managing MongoDB cluster with multiple shards on AWS, which does 1,000+ requests per second at peak. In his previous tenure at TCS, he has worked on developing and deploying internal applications on AWS Cloud. He currently heads the consulting team at Cloud.dat and has been in various large and complex global clients. Some of them being in the top 100 most visited sites in the US. He has architected various solutions on AWS and managed deployments using AWS. Now we also have Prathit and Lakan as our moderators for today's webinar. Over to you, Sankeet.
Thank you, Sharan. Yeah, as Sharan was just informing, there are moderators here, so I'll be beginning with the webinar, and in case you have any questions, please feel free to post it onto the chat box, and I'll be taking up all the questions by the end of the webinar. Right, so coming to the topic of the day, NoSQL Era and Schema Design. So if you look at the databases, evolution of databases, right, from 1960s, there has been a humongous focus on storing data in a robust fashion, in a very secure fashion. So relational databases have always looked at having normalization and making sure that they are trying to store simple and complex data. But they've focused mainly on storing data. There's very less focus that was on reading it, which actually is the reason why NoSQL database have emerged out. So as part of this session, I'll be talking to you about the relational world, and then look at why do we need NoSQL, and then move on, look at a couple of products which are around built on NoSQL databases, as well as we look at schema designing, which is one of the very vital focus area for NoSQL databases, because it's not the same as designing database for relational data. So coming to the relational world, they have focused, as I was telling, there's focus mainly on storation. If you look at normalization, the first normal form, second normal form, multiple types of normalization, which are mainly meant for storing information in a robust fashion. You don't want to repeat yourself. You want to make sure that you're using the storage in a very optimum fashion, as well as the querying, etc., should be managed well. So to support those complex queries for the various applications, of course, databases have evolved, and they have query optimizers, which make sure that any complex query is divided into multiple parts and the database responds really well. And the main focus was to have transactions, because databases when it began, they were mainly entity of corporates. They wanted to store their employee details, or they wanted to store banking information. So in those scenarios, support for complex transactions was very necessary. Is where the asset properties have come out, which says atomicity, consistency, isolation, and durability. Look at atomicity. So if everything has to happen or nothing has to happen, this is to maintain consistency of the database. Now, what do I call as consistency? At any given point of time, the amount of data that, or the kind of data that the database has to remain the same. If I, in case of banking, if I transact, some 100 rupees into a different account, of course, the 100 rupees should be deducted from my account and should be added to the destination account. So if the transaction has to happen, everything has to happen, or both, nothing has to happen. When I say isolation, so if multiple transactions or multiple queries are happening on the database simultaneously, they need to make sure that each of the queries is happening in an isolated fashion. They're not interfering with each other's business. And last one is durability. That is, once written and committed, it has to stay there forever, rather than going back to a previous state. So all this, if you look at atomicity, isolation, and durability, the main focus was on consistency. So making sure that the data is reliable, making sure that the data is robust is where the main focus was on. And schema design also was only data centric. There were never situations where in a relational world you need to worry about what the application is all about. It was only about data. The schema design was only about the data. So once I get an idea of who are all the attributes, what are all the entities and relationships that they have, I can sit and come up with the data design for the whole database without even having a knowledge of what would be the home page be, or what would be the queries like, and how many times would the database be read, or how many times would the database be written. So keeping that in mind, the schema design was mainly data centric. And to make sure that a lot of developers or a lot of administrators be able to work with the databases, there is a common definition languages or manipulation languages that came up for various relational databases. And of course, they've evolved really well. Now, the question is, why are we looking at NoSQL now? How did we reach here? So if you look at Relational World, right? The journey was that you have humongous amount of paperwork that was being done, and people wanted to store it in a IT format or store it in a database. So a lot of data went into the databases, and there were multiple types of users who came in. So initially there were only one single organizational users that were using the databases, but later as the relational databases evolved, there were multiple applications that came up which are using relational databases inherently. Look at WordPress or Joomla, many content management systems, they started using relational databases inherently, which made relational databases as famous as they are. If you look at MySQL, which is common for multiple e-commerce applications or multiple blogging applications, or even banking for that scenarios. If you look at retail, anywhere. So if relational databases have played their part, and once these applications started coming out, there are many technicalities that had to be improved in these databases. Along with the improvements, the database sizes have started increasing because because of the kind of users. If you look at a simple e-commerce application, along with administrators, you have normal consumers who are actually using the application. And depending on the type of the application, there are different types of consumers. And once the social boom has started, there is no limit of the kind of data that comes into the database, and then database started facing issues. So if you look at kind of unstructured data that comes into social applications, that is where database start facing performance issues. So what we understood, or what the industry has understood, is data needs change over time. So when we look at the kind of responsibility that a database has to provide, that need had changed over time. Initially, it was all about structured data, where employee information or banking information, they were all completely structured, and exactly the database or the administrators would know what kind of data would come in and what kind of data would be read and how many times would it be read. But at the moment, once the social boom has started, it was all about unstructured data. The kind of information is not specific to one data type. It was mainly about having different types of users trying to use and different types of data that was coming in. So the support for unstructured data was something that was very, very vital once we've started into 21st century. And the focus was mainly on data storage. Initially, that was making sure that the data was stored in a robust fashion. But right now, if you look at 50 years of databases, we have accumulated so much information that all the organizations are looking at analyzing the data. And relational databases, because they have been a single master systems, it becomes very difficult for them to start writing read queries also on the same node, etc., which makes the analysis part very, very slow. And hence data analysis, because it becomes more important, performance wise, we need to make sure that there has to be horizontal scalability of databases so that the analysis becomes faster. And it is not about robust design anymore, it's about flexibility, because the kind of requirements also change. If you look at the waterfall model, where there is design stage which is properly frozen, right now we are all into agile models where the requirements are not frozen at a particular point of time. You have sprints and you have multiple scrum, which makes sure that the application is changing, and according to the application, it is inherent that the database also has to change and should be flexible. You should be able to change the data model on the go. And instead of features like having multiple transactions or being able to do a lot of join queries, etc., performance was something that that is needed at the moment, because availability is a very vital factor for social networking kind of applications. If you look at something like Twitter, which went down for almost few hours yesterday or a couple of days back, in that scenarios we need to have performance to be a very, very vital factor. And of course, instead of being completely data-centric design, we also have to look at application, which is actually the entity that is querying the database. So the design has to be more an application-specific centric design. So keeping these in mind, the biggies of IT, Google, Amazon, and Facebook, they have recognized that if how much ever capacity we put into one single node, at the end of the day, we are going to reach a point where we cannot put any more resources into one entity. We need to be able to have the system distributed and make sure that there is horizontal scalability. But once you accept that you have a distributed system, you either need to work with availability or you need to work with consistency. Both of them cannot be achieved simultaneously. That's where CAPS theorem, the famous CAPS theorem, talks about consistency, availability, and partition tolerance. Of course, partition tolerance is something that inherently has to be there. You cannot say that if one node is down, my whole database is down. So keeping that as constant, you either work with consistency or work with availability. So Google's Bigtable and Amazon's S3 are the first initial NoSQL databases that have come out, which are more of key value paired databases, which focus more on availability rather than being consistent. That brings us to what are NoSQL databases. If you look at NoSQL databases, they're all distributed, non-relational, highly available, and horizontally scalable databases. And the definition, I've taken it from NoSQLdatabase.org itself. Now that when somebody says NoSQL, because the terminology looks like SQL is something higher and this is NoSQL, the expansion would be not only SQL, it is something more than SQL. So along with SQL principles that you have, you also have to know a little more of NoSQL principles to be able to actually design a NoSQL database in a really good fashion. The characteristics of NoSQL. So they are built to work with large data volume and different types of data volume. It's not just about structured data. It's about having huge text or huge different language processing that can be done. So it's all about large data volumes. They are mainly meant for horizontal scalability, so that whenever you look at data, it's not just residing at one place. The data can be divided and put into multiple nodes, so that I can run queries parallelly on multiple nodes. Having said that, it's very inherent that if I try to divide my data in a relational scenario, I need to do it in the very beginning because of the relationships. Now here, because we are letting go the whole relationships concept, data can be divided horizontally in a very easy fashion, and databases, almost all the NoSQL databases support it. And of course, asynchronous inserts and updates are something that even relational database have been working with. But here it's more about reading rather than writing. These databases try to support a very high performance for reading. The way they use the memory, the way they use caching systems are far different than how relational databases use. Hence, these databases support a lot of querying rather than inserting and updating. And atomicity perspective, here the queries would be atomic to a single table or a single collection. We'll be talking about the terminology. And the word schema-less, this is a very widely wrongly understood word. When somebody says schema-less, people understand that yes, I can write anything to a NoSQL data. Now, of course, yes, the word schema-less means I can write whatever whatever I can into a database. But does that mean that I can write into an employee application or employee details application? Can I write product details? Not really. So you need to still think about a schema by knowing what the application is, but the database wouldn't complain saying that this kind of data should not be entered. Database would accept any kind of information into the database. So that is where this webinar is all about, coming up with the right schema for a particular application. And because there is something called ACID for relational databases, NoSQL guys have come up with BASE. It is again acronym itself, whereas where BASE says basically available DA soft state, that is I'm at any point of time I'm in a soft state, I'm not consistent, and I will become eventually consistent. There are various types of NoSQL databases. In general, they are divided into four: wide column stores, graph databases, document stores, and key value stores. Key value stores are something that industry has been working with for quite a while without even having the knowledge that they were NoSQL databases. If you look at Redis, it's an in-memory data caching system where indexes are stored inside memory. Even database indexes, for that matter, they're all key value pairs which are stored inside the memory, and they are just key value pairs, and they're very good with scanning through them. We can scan through them very, very fast. They are very high performing in terms of scanning. There's nothing else that you can do. There are no other features that are available for key value stores. They're mainly meant to store very small information, non-relational information, and being able to scan very fast. When you look at document stores, they are, when you combine multiple key value pairs, we can call that as a document. If you look at JSON or XML, they are good key value pair stores which are combined. When I combine multiple key values, I can talk about an entity and say that this entity has the following properties. For example, if I look at a HR system, I can clearly say employee name is something or employee ID is something. So these are all key value pairs. A set of key value pairs can talk about a single employee. So all the document stores are quite famous at the moment. They are the ones which are trying to get into the relational space where relational database have done a good job. Document stores would be a good replacement in case you are looking at a solution to replace your relational database. When you look at graph database, on the other hand, they are very highly relational, which have a lot of relationships, even more than relational databases, which are very good for analytical purposes. Even the wide column stores, they store information on column basis, which are very good for analytics. And there are not more than, of course, there are more than 150 NoSQL databases which are listed down in NoSQLdatabase.org. Because, of course, when I remove the relationships or when I remove the philosophy of relational databases, I can store information in any fashion. So keeping security, keeping availability, and keeping partition tolerance in mind, I can very well write data in whichever fashion. And of course, if applications are able to read it, I have a NoSQL database with me. So with that as as a philosophy, there are more than 150 databases. Anything that needs that suits your need, you can very well go ahead with it. It's all about it's all about what you need, right? When you look at different types of databases, where should I go with what? When I look at document databases, they are very good with continuous reads and writes, and they can very well have varied access pattern. That is, number of reads and number of writes can be very, very varied. They support a lot of data types, and they also have simple CRUD operations just like any relational databases, and they are quite fault tolerant. Now, document in case you are looking at any e-commerce application, or in case you are looking at social kind of scenarios, document databases would be quite helpful. Even for organizational database, also document stores would be quite helpful. When you look at wide column stores, yes, they are mainly meant for analytics because you're having higher write availability. They can span across multiple data centers, and you can have a lot of streaming into the databases, and of course they are also having a lot of fault tolerance. And when you look at mapping and reducing also, if you're looking at big data kind of scenarios where I want to do analytics on humongous size of data, which is again having a good velocity and variety, I can go with wide column stores, which help me in being able to read a particular column and calculate averages or come up with whatever analytics activity that I want to do. Wide column stores would be very helpful. Key value stores, on the other hand, they are very good with small writes, and you can very well have very high performing queries on them. You can scan through them very fast. So caching or any other in memory or on disk caching kind of things is where key value stores would be helpful. Having said that, of course, relational databases, the biggest advantage is they have complex transactions. So when you have complex transactions, you need to divide those transactions into multiple single transactions if you are going with NoSQL databases. And if you go with NoSQL databases, you need to let go consistency. So in case you have an application, for example, if I take a banking application, of course, consistency is something that is very vital. So I can very well go with document databases. Document database does support higher consistency in terms of replication, and when you're really trying to read after write. But the problem is you will let go availability. So you can very well say I want my database to be completely consistent, very highly consistent, but know that you might also let go availability, and you may not be able to get the full effect of using a NoSQL database. So SQL database are still good with applications where there are a lot of transactions or a lot of consistency that is needed. In all the other scenarios, NoSQL databases would be really good. So if I plot a graph against performance or scalability across supported features of a particular database, the graph would be something like this. If you see there's a steep curve after a particular point of time, you know that in that area, if you increase the performance, or if you increase the features a little, if you add little more features, you will let go of a lot of scalability features that the particular database offers. So key value store databases lie on the topmost part of it, where they don't have a lot of supported features, but they have a very good area. Their main specialization is in being able to scan through them faster and being able to respond to queries faster. The RDBMS, on the other hand, they are on the other side of the spectrum, where I have so many features, I have huge amount of transactions that I can very well do, multiple complex queries that I can very well write. But after a particular point of time, you will start seeing performance issues with relational databases. And document stores, on the other hand, try to where as many features as possible without compromising their scalability. They try to lie in that area, and they turn out to be a good replacement for relational databases. Let's go look into few document stores that are already available in the market. For that, in general, all the NoSQL databases try to use JSON, because JSON is a good way of representing attributes of a particular entity. So here, if I look at a simple employee detail or student database, I have an underscore ID. Again, when you look at underscore ID, it depends on the database. MongoDB generally uses underscore ID, which is mandatory for each and every entity that you write. And so name, date of birth. So there are a lot of data types that are supported. If you see, there are strings, there are numbers, there are boolean. If you look at representative, that is true or false. I can really write null values are also supported, although it is not advised to have null values in the database. You can have array of multiple objects, whether it is strings or numbers or documents itself. Array of documents also you can very well write. Date and object ID are something that are supported by binary JSON, but of course JSON also supports it right now. So object ID is ID that we are looking at. That is an object ID, which is a combination of the host ID along with the name, along with the date and time, etc. Object ID. Terminologies. So generally, we look at when we call a row in a relational database, we call it as a document here. A document is a single row which has details of one single entity, in a key value pair fashion. Multiple documents together form a collection, which is a table in relational scenario. and multiple collections together form a database. So with this as background, there is a lot of, I think we'll look at 3 different NoSQL databases that are there. DynamoDB being the first one. DynamoDB, again, it's an Amazon product. It's by Amazon Web Services. It's a service offered by Amazon. So it's a fully managed NoSQL database, which is mainly about their predictable performance and seamless scalability. When I say seamless scalability, so you don't have to worry about when you go with DynamoDB, administrator doesn't need to worry about how to store the information, or what about my disaster recovery, or what is my performance. He needs mainly to worry about number of input-output operations per second. And so how many input-output operations, or whether it is read input-output operations or write input-output operations, the business has to decide what is the user base and how many read operations per second would I get and how many write operations per second, and I will tune my database to actually support that capacity. And I can also have seamless scalability. That is, if I want to increase the throughput at a particular point of time, I can have automatic scaling that is attached to it, which basically looks at the metrics saying if I have my read capacity reach 90% of my allocated capacity, I want to increase and keep it. So in that ways, my database will make sure that whenever there is need for higher throughput, my database automatically scales up, and I don't need to worry about their storage or recovery, etc. Everything would be taken care by Amazon. Now, of course, when you look at NoSQL database itself, the concept says flexible schema. So here they're all JSON type data itself. You can very well have flexible schema inside it. Very highly scalable, as I was telling about throughput provisioning and scaling automatically. The data which is there, which you write to DynamoDB, is stored across multiple data centers or multiple availability zones, and which again is managed by Amazon. As an administrator, I don't have to worry about it. It's for making sure that the database is fault tolerant as well as the database is highly durable, and the data across is divided and stored across in multiple availability zones. But I would be it is my application that is trying to access, so I need to make sure that I'm coming up with the right key to be able to shard my data or distribute my data horizontally. So those keys are something that I need to worry about. So schema design and coming up with the right shard keys is something that I have to worry about. Also, of course, they are all using solid state disks, and so the performance and the overall user experience with the databases would be far better. Moving on to Cassandra. Cassandra, on the other hand, it is still a JSON type database, but it's not a single master system, or it's actually a masterless system for that matter. Very highly scalable NoSQL data store where things are stored in a loop fashion. They're all stored inside multiple nodes which are part of one single network. Call it as loop topologies, and they're all data center aware. They know which each node has information about which data center they're part of, and all the nodes are same. So every node is a master, every node is a slave. So there's no place where I need to say that there's a single master system. I can write to any node and I can read from any node, and the nodes are aware of the kind of data that they have. In case they don't have the data, they pass on the request to the other node so that I still get a response from the database. But the number of replication factor that I want to have, or the number of copies of a particular data I want to have, as an administrator I need to decide that. And of course, the key space based on which Cassandra has to divide, also that is something that I have to come up with. And I can add and remove nodes at any point of time. Cassandra takes care of including the new node and start dividing the data across that. And also when a node has to be removed, Cassandra takes care of taking the data from that node, migrating it to all the other nodes, and making sure that the data is still safe. So to give a simple example, I have a two data center database is spread across 2 data centers, and my DC1 has all the nodes and DC2 has replicated data in all the nodes, and I can read from anywhere. Lastly, MongoDB is a very widely used database on the planet at the moment, NoSQL database. It's of course a document store, and very high performance, high availability, and automatic scaling is something that MongoDB focuses on. So automatic failover and node recovery are also inbuilt features of MongoDB. So MongoDB is NoSQL database which can be spanned across multiple data centers, of course multiple servers. They can also have complex data which is of when you put it into JSON, and they started supporting a lot of indexing features, text indexing, geospatial indexes, where you can also have graphical kind of information being retrieved from the database in a very easier fashion. And they work with JavaScript, simple JavaScript. In case a developer already has an understanding of JavaScript, MongoDB works with JavaScript, so overall the development effort also is easier. The kind of language that developer needs to learn is nothing different from learning any kind of or any kind of backend coding language like Java or C++. They can very well, in case they have JavaScript knowledge, they can very well start working with MongoDB in an easier fashion. So in general, document stores are widely used for mobile applications, e-commerce application, analytics. If you have content management systems, of course, they are also wherever there is asynchronous inserts and updates that have to be done, like gaming applications or social networking applications. Archiving is something, archiving and also analyzing the archives is something that NoSQL database are good with. But know that there are no joins or multi-object transactions. They wouldn't be there. So along with these three products, there are multiple other, like Couch database, which is again a JSON store database where the queries are based on HTTP request itself. So all the developer has to do is send HTTP queries to a database. So it's a database that runs on port 80. So there are multiple databases that are there, and you can choose anyone based on the requirement. Once you choose a particular database, then comes the schema design part of it. You need to make sure that you understand the application completely. So when I say understand the application completely, when you look at relational databases, the first question that you need to ask when you look at schema designing is who are all the entities, what are their attributes, and what relationships would they have. So with that as information, I can do a relational schema design in a faster fashion. But when it comes to NoSQL schema design, I need to focus on the application. What would be the home page? What would be the user funnel like? Would the users, how many users would be going to this particular page? How many users would be going to the second page? So this kind of information you need to know. Before getting into exact how to design a NoSQL database and an example, a few terminologies I think I've already spoken about, a couple of them, where collection, row is analogous to document here, index is index itself. There is a concept key. Here we call it as reference. But again, there is no hard foreign key relationship there. It's only a soft reference that the application puts into multiple places. But in case information has to be brought out from multiple places, of course, multiple queries have to be written. And when you're joining here, so instead of joining data from multiple places, in NoSQL scenario, you embed that particular information also into the parent table or the parent collection. Right, as I was telling, application is very important, plays a very vital role in NoSQL schema design. It's not just the design, it's about how the application is using it, how the application is accessing it, how the application is reading and writing the data into the database, and how are the how many queries are happening. That is, what is the range of reads and writes that are happening compared to what is the range of analytical kind of information that is coming out. But before that, of course, there's a limit of amount of data that you can put into one single row or one single document. So you need to consider that document sizes and other limits before coming to the NoSQL schema design. So with that as a background, let's try and do one schema design. Now before that, please note that there are no joins. So when there are no joins, you need to make sure that you are putting related information at one place. What do I mean by related information? In a single query, if I want some information in a single query, that is related for me. So just I think the example would make it very clear. So I'm calling this application as connect.in. It is it's any social networking application that you would have thought of. So if you look at connect.in, maybe my home page where I have a user who is logging in, and he has his statuses, and I'm showing the top 3 statuses here, or top 2 statuses, and top 3 comments of each of the status. And of course there is photos, and this other profile, my profile and my friend profile, etc. And this is how my profile looks like. When somebody goes to my profile, he looks at his own bio along with few statuses that he has posted. And if he goes into his photos, he'll be able to see all the albums. In case he goes into one album, he'll be able to see multiple photos. And if he goes to his friends, he'll be able to see a list of his friends also, as well as his friend's profile. If he clicks on one friend profile, he'll be able to click on it and then look at one single friend's details. Now with that as a scenario, if you look at what kind of tables and what kind of columns will come up with for relational database. So in a relational design, first of course I'll have the users table, which has all the user information. With of course in the end you look at current avatar, where I have the location of the avatar, and I might be storing that in a disk somewhere. I have friendship information where I'm relating IDs with user ID and friend ID, and of course I have a friendship ID also, so that I relate two users saying that these both are friends with each other. And I have status updates table where I store information of multiple statuses that are posted by a particular user and comments on those particular statuses. So I know that which user ID has posted which comment on which status at a particular point of time. And of course I have photo albums which have photos inside them, and I have an owner for the photos and multiple images inside the album, and the relationship goes on. So if you see, in a relational schema design, I had to come up with 6 different tables. Now every page, if I go to the first home page, my home page shows my own users, top 3 statuses along with top 3 comments. So I need to get top 3 comments of friends, right? So I'm most probably joining users, friendships, statuses, and comments. All these 4 tables I'm joining, and I'm getting the information which is just needed for home page. So because in NoSQL design I don't have the flexibility of doing joins, I need to put related information at one place, yes, and also look at considerations of the document limit size. So if I want to design the same schema for NoSQL database, first thing I want to know is few thumb rules. Again, the thumb rules might be useful when you are at a particular point of time, but keeping the application in mind would very well help you in coming up with the right schema. So in a relational database, in case you have one-to-one relationships, I can very well put those information into one single place that I would embed. So going back to the relational design, in case I have, for example, I have users, maybe I have, instead of having just one users table, I might have a users table which has just the user security information like password and first name, last name, email ID, and I might have one more table where I have user details which speaks about their hometown or city, etc. Where I'm dividing the same users table into multiple tables. So there I might be having one-to-one. So in a in a NoSQL schema design, wherever you have one-to-one relationships, and of course that information is needed at a particular point of time, I can embed that and put it into one place. When you have one-to-many relationship, I can either embed them as an array of things. That is, if I have one user having multiple statuses, I can have an array of statuses inside one single inside the same document, or I can really have it in a different collection and try to relate them by linking. And when you have many-to-many, here you need to choose parent and child relationships. So 2 one-to-many relationships that you can come up with, and you need to choose which suits better as a parent and which suits better as a child, and then you either try to go back to one-to-many, and then you either try to embed or link. So with these are thumb rules. Also, although thumb rules are very good, it mainly comes up to the experience that you're working with the NoSQL databases. So if you look at here, so for the same database that I have in relational database, I can come up with a huge NoSQL schema like this, where I have only one collection which says users, which has full information saying _ID, username, password, etc., etc. If you look at friends, I have IDs of friends IDs as an array, because it's one-to-many. I had an array of friends, and of course it's not a hardcode foreign key and child key relationship. In case I have to get the details of friends, I have to post 2 queries. First query to the users collection and get the friend IDs, and again one more query to the users collection again to get the details of those friends. Similarly, I have status updates, and I have posted time, and under each status update I have the comments also. So I posted one single status here because the size of the data. what is the time that is posted, what is the text that is my first status, and the comments under the particular status, and of course the photo albums also, same album ID posted on and the photos under that, and of course the comments of the post photos also. So if you see, I was able to bring everything into a single collection, but the question that you need to ask is the single collection good for my application? So if you look at first thing, as I was telling, there's a limit of document sizes. So when you go with MongoDB, there is a limit of 16 MB of each document size. Now 16 MB of JSON data. Now, that actually is very huge, but does it make sense for me to write all my statuses in a single place here? What is related? The whole point of saying keep the related information at one place. According to my homepage, I am showing the top 3 comments maybe, or I'm showing the top 3 comments of a particular status. So I don't need to write all the comments here. I can very well have one more collection which just talks about comments of the user. So it completely depends on the application. So if you don't have that kind of scenario, yes, you can really come up with a single collection. But know that single collection may not be a solution all the time. So here, the possible collection could be that users, in which I have user details, the statuses, and the corresponding comments of the statuses, where I can also divide the comments of the statuses into top 3, which are part of my users collection, and I can have a different collection where I have the remaining comments of a particular status. I can have a status ID there and have comments there. Along with that, I can have one more collection which just talks about friendships, because I'm not querying for friends at a particular, along with the status also. I'm only querying for friends where I'm going the list of friends. So there I can have users to friends mapping. Similarly, photo albums also, my query could be separately for photo albums, where I have the ID of the user, the owner of the albums, and of course I can also store comments along with that. So again, here also I can have top 3 comments and include the comments into the comments archive, where I have multiple other comments of that particular database. So these could be the possible collection. It is only possible collections. It's not like these are the only collection that you can have. It's all about your application. It's all about how your users are using the application. And if you feel that a lot of people are actually requesting for more and more comments of the status or particular photo, you can very well put all the comments into the status table itself. So having said that, know that I can. So this is not something that is completely desirable. So it is very easy to tell what not to do in NoSQL databases, because a single collection may not be the solution all the time. What to do completely, how to come up with your schema design completely depends on your application. So understand your application properly, and then you can come up with a schema for NoSQL databases. So that totally, when I want to talk about the 5 points that a particular how the application accesses data, that is the reading of the data, how it happens, how does it manipulate the data. Look at horizontal scalability. You know that you can divide the data and put it into multiple places. So leverage horizontal scalability, come up with the right shard keys to be able to reach a particular shard. So when you're sharding, the main focus that you want to have is my query should reach only a single shard. It should not go to all the shards. So try to come up with a schema, or try to come up with the shard key in such a way that most of my queries, which are based on indexes, go to a single shard, and then my database responds to it. And one collection may not be the right schema at all the times. It could be the right schema, but it may not be all the time. And of course, leverage agile methodology. So even adding a particular column or adding a particular database is very easy in all the NoSQL databases. All I have to do is my application developer should start writing new data. They don't have to worry about the existing schema, because databases are schemaless. They can very well start writing new information, and know that. So in that ways, you will be able to evolve your database along with your application requirements. So it's all about application and data, and also how the application goes through the data. So that's how. So in case you're doing your NoSQL schema design, I hope these main focus points would help you out in coming up with the right schema for NoSQL databases. Having said that, thank you for attending, and I hope your your NoSQL journey, which is the beginning of your NoSQL journey, is smoother with this particular information that you have.
I hope it was a valuable one. A feedback form has been sent to all the attendees, and I kindly request you all to fill in the forms and send it back to us. And the other thing is that we also have an early bird of 10% off on any of the courses you register within the next 24 hours. Right. So thank you all once again. So please contact us on 08880002200 or drop us an email at sales@cloudthat.in. Thank you.
Mr. Amit, there is a question which says that are there solutions which are NoSQL databases on AWS and Azure? The answer is yes. AWS has a document store database which is DynamoDB, and of course Azure also has similar solutions on for. There is one more question. Conceptually, doesn't this approach tie the schema tightly to the application and its usage? Should the data be loosely coupled? Ideally, when you look at NoSQL schema design, yes, it is the application that is going to use the data. So yes, there is very high need for the data to be highly coupled with the application. But I understand the concern of Mr. Jagadishan, where if it is tightly coupled with the application, changes might be difficult. But no, to evolve, NoSQL database are quite easy to evolve. So you can make changes to your schema. There's nothing like modifying a particular schema. It is all about writing the new data. So your evolving will happen very easy fashion. But at any point of time, even during the evolution, the database should be tightly coupled with the kind of queries that are coming up. So of course it has to be coupled with the application. Thank you, Jagadishan. That was all right. In case we don't have any other questions, I think we can very well wrap up. Thank you for joining the